So scatter plots show the relationship, thank you, Corbin, between dos variables. Good news is, Corbin, you didn't miss anything. I literally just started. Okay? Scatter plots is just the relationship between two variables. You know what's also a relationship between two variables? Literally anything that is a linear equation, aka y equals mx plus b. So scatter plots are closely related to y equals mx plus b. Now they are so similar that a positive scatter plot relationship will look very similar to a positive what? Say louder. Like a positive slope. So a positive relationship scatter plot is eerily similar to a positive slope. What would a negative scatter plot relationship resemble? A negative slope. It's just the only difference is instead of a line, I have a bunch of crazy dots. Now the one thing that is different, however, is neither, which is literally everywhere, where you cannot determine a relationship at all. It's literally just everywhere. Okay? Now, within scatter plots, we can't technically automatically create an equation from just random dots on a graph. However, we can create what's called a line of best fit. So it is the closest line that we can make to a scatter plot using y equals mx plus b. So we're still using y equals mx plus b. Okay? Now, the definition for line of best fit is given a positive or negative correlation. Correlation is a synonym for the word relationship. Okay, synonyms, English. It is possible to write a prediction equation. Now, this equation is going to be in the format of y equals mx plus b. So given a positive or negative correlation, aka relationship, it is possible to write a prediction equation in the form of y equals mx plus b. Okay? Now, our first example here is also going to provide you our test-taking strategy to solve these problems on the STAR test, on any other future test, including the one that you're going to take on the 28th now. Okay? So the data in the graph below shows the resting heart rates and ages of a group of 20 people at the gym. Which line best represents the data? Now, this extra sentence right here is your test-taking strategy. This is the test-taking strategy for these problems. You're going to graph each line to justify your answer. Now, I'm going to go ahead and grab a sharp edge, okay, and I'm going to graph each line here. So I have a y-intercept of 80, and then I have a slope of negative 2/3, so I go down 2 over 3, down 2 over 3. Okay, and I'm just going to continue that process. Now, how many dots do you technically need? You only need like 3, but I went ahead and did all of them that fit on the graph. And then I'm going to connect said dots and label that line A. Now, do you think line A fits the data that we have? No, so line A is out. Line B has a y-intercept of 75, but that has a negative slope of 1/3. So I'm going to go down 1 over 3, down 1 over 3, down 1 over 3, down 1 over 3. Then I take my straight edge, create my line. Do you think line B fits the data very well? Yeah, I do too. I mean, that thing is smack dab in the middle, isn't it? You don't think that's in the middle? Huh? Your line is a little not? No. This is why I grabbed a straight edge. I just grabbed one of my passes to the counselor or whatever to make it more accurate. Okay? Or a calculator. The back of the calculator works too. Line C is similar to line B. It's just that it'll be starting up here and it'll be on the top side of the graph, which doesn't match the graph because it doesn't go through the middle. Okay. Line D is one that I do want to draw. It is y equals 50. I got a variable opposite of a constant. What world do we live in now? Hoy and Vux world now, right? Okay. Now I have y equals. So is it Hoy or Vux? Hoy, because the last letter tells us the equation. Y equals. Okay. This is a zero slope, which is what type of line? Horizontal. So at 50, I'm going to draw a horizontal line at 50. Just so you can see graphing a horizontal line. Elva, do you have a question? You don't? You were sitting here like this the whole time. That's funny. All right. Another example. Okay. Now, Coach Kimball is all about doing things smarter. Yeah. Work smarter, not harder, right? Yeah. Okay. This relationship. Positive, negative, or none? That hat really turned your brain off. That is a negative relationship. Okay, that is a negative. Okay, now, Issa said that these are similar to what? Slopes, right? They're similar to slopes. So if I have a negative relationship, what type of slope will I have? Negative. So if I have an answer choice with a positive slope, is it even possible to have that as an answer? No. So why do I need to graph the unnecessary lines if I know for a fact that they won't be a part of it? This is called process of elimination. Eliminate the most obviously wrong answers first. Okay? Makes things easier. So now I only need to graph 2 lines. I don't need to graph 4. Make it easier. Work smarter, not harder. Okay, first one, y-intercept of -2. That's right there. I have a -3 over 5 slope, so that means I go down 3 over 5. And I work in the reverse, up 3 over 5. Draw that line. That was answer choice B. Does that line seem to fit the graph? No. I was waiting for more than just Jordan to answer. No. Jordan's the only one answering back there. Okay. No, it does not fit the graph. So is B an option? No. Now, again, let's think logically here. Okay. I've eliminated A and C because their slopes were wrong, and I just eliminated B. If I'm on a test, okay, and I eliminated literally all the other answer choices to where I only have one left, what do you think is your answer? That the one that you did not eliminate. Okay. Now, if you're one of those people that like to double check your work, let's double check our work real quick. All right. I'm at -2. Boom, -2. I have a -5/3, so that means I go down 5 over 3. which will take me off the graph, so I work in the reverse. Up 5 over 3, boom. Does that fit the data better? Yes, it's more in the middle of the graph. Okay, so just to double check our work, yes, that is our correct answer. A and C wouldn't have even been close because they would have been going this way, which would have made 0 sense. Turn the page. Let's look at number 3. Skip 2, look at 3. Skip 2, look at 3. So if I look at the graph and I take my edge, okay, and I try to put it like the last dot to the beginning dot, what direction are we going? Up, right? And anything that is going in the upward direction, left to right, is positive. Okay, so it's not flat enough to be 0. Okay, it's not flat enough to be 0 because there is an upward trend. Okay, now what answer choices can I eliminate immediately knowing that it's a positive relationship? B, D. Bueno. Fantastical. Of course you did. Okay. Now, I have 2 remaining. Both of them do not have a y-intercept, so we start at the origin. Okay, we start at the origin. Now, last class, we talked about this. What type of equation is this? We said it's positive, not 0, so it can't be Hoy or Vux. We talked about it last class. If I have an equation with no y-intercept, it's proportional, which is direct variation, which is y equals kx. Y'all learned that last class? Oh. I forgot. Yeah. See, this is why we're extending our unit a day. Okay, so these are direct variation equations, which means we start at the origin. Now, if I have a slope that is a whole number and I need to do rise over run, what do I put that whole number over? 1. So now I have a rise of 4 and a run of 1. So I'm going to plot that. Rise of 4, run of 1. Now I work in the opposite. Then I trace my line. Does that fit? No. Okay. Process of elimination tells me what's my answer.
The 1/2.
C. That's also 1/4.
4.
Not a half. Okay. Then I can double check my work. I can rise 1, run 4. Does that fit the graph better?
Yes.
Yes. So that is my answer. Questions, comments, concerns, or tribulations?
Nada.
Bien. Bien does not mean thank you.
Whoa, my bad. Actually, it just means good. That's not like
This is the time of the notes where I want everyone to make sure they have a calculator. So everyone get their calculators and turn them on. Get your calculator and turn it on. Then I want you to follow my steps exactly. When the calculators are on, let me know.
my calculator on.
Sweet. Everyone hit second plus 7, 1, 2.
Did you just reset? 7
I just cleared all the information on there. So if anyone left like an equation or something in there, it deleted it. That just clears the whole thing. I didn't reset the whole thing. I just cleared the info that's in there. Okay? So I wasn't resetting, I was just clearing it. See how it says cleared? No. RAM cleared is different.
I know. That's why I said
If I just hit the clear button, it does nothing but clear what's currently presented on the screen. But it gets rid of that one thing. This clears everything at once. Okay? All right. Now, enough of the nonsense questions about the clear button. Okay? I need everyone to click on the button mode. Okay, do you see all that? Mode is to the right of the second button. Scroll down to where it says Stat Diagnostics. And you see how it says it's off?
Yeah.
Hover over on and hit enter because I want it to be turned on.
Or to change the language.
Don't do that. Now to get out of this crazy screen, hit second mode again and it gets you out. Woo! Technology. All right. So now that we have refreshed our calculators for the notes, okay, let's talk about linear regression. Now, linear regression is a method used to find the line of best fit given a set of data. This can be done through your graphing calculator and will create the most precise equation possible. Now, I'm going to put a little side note. We are going to be rounding to the tenths place. Rounding to the tenths place. Now, when you find linear regression, you are going to be presented with 4 different variables. 3 of them are ones that we actually care about. The first variable that the calculator gives us is the letter A. But for us, the letter A actually represents M, or slope. So whenever you see A, when we find the linear regression, whenever you see A, that's your slope. Okay? B is still B. It's your y-intercept. R is your correlation. R is your correlation coefficient, aka the number. Okay. Now, correlation coefficient is talking about if we have a strong or weak relationship. That's talking about strong or weak relationships, and we'll talk more about that when we find our first set of data. Okay. Now, here are our calculator steps to enter the data. I'm not going to read that because we're going to do the steps together when we answer problem number 1. Okay, so problem number 1 says the data in the table below shows the average temperatures in the northern latitudes. Okay, we need to find the line of best fit, aka y equals mx plus b. We need to find that given this table. Now, instead of us doing it by hand and finding the rise over the run, then finding the y-intercept and blah, 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 we're going to find the literal most exact answer because these don't create a straight line. It's a bunch of dots on a graph. They don't create a line. It's a discrete graph. So how do we create a line from a discrete graph? I'm glad you asked. Everyone take their calculators, make sure they're on, and hit the stat button, which I am pointing to right now. I am pointing to the stat button. So if you're wondering where it is, I'm pointing at it. Click it. So now you see that it's hovering over edit. We're going to go ahead and hit the enter button to have our table. And now we are going to create our vertical table in the calculator using this stuff. All this is your X and Y table. How are you already have numbers in there if you cleared it like I told you to? You didn't clear it. Ah, thank you, Tim. Okay, so you should have cleared it, Tim, like I asked you to. So here we go. When I have a horizontal table, what values are my x values? The top or the bottom? The top. So the top values are my x's, the bottom values are my y's. Now, in our calculator table, L1, it's called L1 because it's list number 1. And the word list starts with an L. That's why it's L1. List 1 are my x's. So I'm going to put all my x's who live in Texas, and I'm going to put them into list 1. And I'm going to put them in the order that I'm given. You understand? Put them in the order I'm given. So I'm going to go 0, hit enter, 10, enter, 20, enter, 30, enter, 40, 50, 60, 70, 80. And then I'm going to hit right arrow to get into my Y side of the table, aka list number 2. And I'm going to put all those values in there also. Now, again, put it in the order that it's given to you. So 79, 81, 79 again, 68, 58, 43, 28, 13, and 1. Now, when you're all after y'all input the stuff, let me know. Joking.
I accidentally put 90 here. How do I get it out?
Just type in a new value. Hit delete. Or clear. Hit clear, see what it does.
And it's not there.
You have to type the number in. You have to go in the number, and then you have to type the number and press enter. And there's
0 to... delete. Okay. Just hover over it and hit delete. All right. Sorry to make you jump, Brett. Now to find the actual equation, because linear regression is just the calculator version of finding y equals mx plus b. So we have it all do it for us. So watch this. We're all going to hit stat again. And now we're going to hit right arrow to calc, aka calculate. So right arrow to calculate, and it gives you a new list. Now we are doing linear regression. Which selection looks like the word linear regression? 4. Linreg. Huh? I want Lin, L-I-N.
What do we do after this?
Hit stat. Hit stat. Hit stat. Okay. Now hit. I'm helping Alva real quick. Now go to the right for calc. Do you have this list now? Okay. Now I scroll to select number 4. The reason why I'm choosing number 4 is because what's in parentheses? AX plus B, which is similar to MX plus B, right? And I said at the beginning that A is our slope, M. A is our M. So we choose 4 because it says, hey, it is going to be this equation right here. Okay. I do believe that 8 gives you A plus BX, so it makes your y-intercept the slope, which is incorrect. Okay. And 9, I have no idea what it does. I just know I use 4 and I never choose anything else. What the? Now, once you go over number 4, hover over it, hit enter. Now, this part, in the past, they used to say just hit enter 5 times. You don't have to hit enter 5 times. You can just scroll down to calculate. Okay? This is just to make sure that it's saying, hey, my x's are list 1, my y's are list 2. Okay? And then I'm going to hit enter to calculate. And then I should have 4 different variables presented to me. Does everyone have A, B, R squared, and R?
yeah.
Now, we only care about 3 out of the 4. A, B, and R. We do not care about R squared. Okay? I only care about 3. Now, here's what I want us to do. I want us to put right here. A, B, and R. Now, what did I say we were going to round everything to? The tenths. So looking at the A, what do I have? Negative 1.0 what? 7. Because we're rounding to the tenths. No, hundredths. Did I say round to the tenths? Hundredths. Hundredths. My B. What is our B?
92.86.
Correct. 0.87 because we're rounding to the hundredths. You must have inputted a value incorrect in your table. Now, what is the R? Negative 0.97. Okay. Now, the line that best fit is y equals mx plus b, where m is the a value, b is still our b. So to create the equation, y equals negative 1.07, that's our slope. Negative 1.07x, and then my b is plus 92.87. Now, what on earth do we do with the r? No. Here's what we do with the r. Okay? Now, if r is close to negative 1 or positive 1, it is a strong correlation. So think of a number line. Okay? I have this right here. I have 0, I have negative 1, and I have 1. Okay? The closer I am to 1 and negative 1, the stronger we are. The closer to 0 I am, the weaker I am. So if r is close to negative 1 and 1, it's strong. If r is close to 0, it's weak. Okay? Next thing I need to talk about, though, is do I have a positive or negative here? Negative. So when I am giving you information and I tell you the correlation is this number right here, your response to me would be I have a negative, or sorry, strong or weak first and foremost. Strong, because it's really close to negative 1. Strong, and then you tell me if it's positive or negative. Negative correlation. Now, to give you an example real quick, if I give it to you as a graph. All these dots are pretty close together, right? Would you call that strong or weak? Strong, because it's really close together to almost making a solid line, right? So the closer knit the dots are, the stronger the data. Now, if I had more dots out here, okay, does that still look like it's going negatively? Yes. This still looks negative, but do I look more spread out? That's a weak correlation. So that's when our correlation is close to 0. Everything is not close together. Now, what makes it neither is if I had more dots way out here. Okay? But because I have the dots are still kind of centrally located in a negative direction, that's it. Now, your negative and positive correlation relates to your slope. If your slope is negative, your correlation is negative. If your slope is positive, the correlation is positive. It's connected to your slope. Okay? So, I keep doing that. So again, our slope was negative, so our correlation is also negative. Okay? Now, That's all that the R is for, telling me if it's strong or weak. That's it. That's all we use the R for. Nothing else, so don't freak out. What we really care about is the equation, because we can use this equation to solve for a missing value. Now this says estimate the average temperature. Temperature is your X or your Y?
Y.
The Y. Okay, so for a city, I have a latitude of 48 degrees. Now, I know it says 48 degrees, but we said the temperature is Y. Now, what is this then? The X value. So if I want to solve for when X is 48, we will do Coach Kimball's rules of math, and we will substitute 48 in for X and solve. So just plug it in and solve. I just go to my calculator and I start typing negative 1.07 times 48 plus 92.87. Literally just plug it in the calculator and hit enter. Where are we located at? Or what's the temperature in that location? 41.51 degrees. Yes.
How do you get
What
out
did I
of
just say? What word just came out of my mouth? Yeah, Brett.
How do you get out of here to do like the math thing?
Just
Get
type.
back in?
Just type in negative. Start typing negative 1.07. Just type it,
Oh.
and it pops up. As soon as you start typing something else, that screen disappears. All right, let's look at number 3, please. Let's look at number 3, because number 3 is a little different. Okay? The data in the table below shows the number of graduating seniors at Canyon Valley High School since the year 2012. Since the year 2012. I want to find the line of best fit, and then I want to estimate the number of graduating seniors in the year 2025. Now, because I see the word since, okay, I am not going to put 2012, 2013, 2014, 2015, 2016, 2017 into the X values. Because of the word since, the year 2012 now becomes my 0 year. aka my starting year. Now from 2012 to 2013, how many years passed? 1. From 2012 to 2014, how many years passed? 2. So on and so forth. Because of the word since 2012. That is telling you that year 2012 is your starting value. Year 0. And when we type our stuff into the calculator, we will use these numbers, 0, 1, 2, 3, 4, the years that have passed, as our X values. Okay? So that's just a little extraness. So who can tell me, if I want to type this stuff into the calculator, what do I do? Someone walk me through the steps. Mode. List. What? How do I get to list through mode? Stat. Okay. Now what? Edit. So I hit enter. Okay. Now I have some values in my calculadora. How do I get rid of these values? Good question. I'm in L1. I want to clear the whole thing. Instead of hitting clear down, clear down, clear down, clear down, I'm going to scroll up to L1 and I'm going to hit the clear button, and then I'm going to hit enter, and look, it clears it for me. Don't hit delete. It will delete the list. Hit clear. So again, look. Eyes up, Tim. So you're not turning around and saying how. Okay? That's where my cursor is. Right? I hit up arrow. Now I'm up here on the list. I hit the button clear and then hit enter. See? It helps to look up every now and then. What do I do now? X and Y. 0, 1, 2, 3, 4, and 5. What are my y values? Okay, got it. Is that the only y value? Mm-hmm. Uh-huh. 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 How did I get those? They were in the table. How did I get to what? Hit enter.
How do you get to the table? How do you get to the table?
How do you get to the table? This is why you got to follow along as I do this. Hit stat. Hit enter. Now scroll up. Hit clear. Now hit enter. Cool. Now scroll to the left, up, clear, enter. Boom. Now input the table. So I'm going to give y'all a second to input the table. Y'all want to see something really cute? Maybe. Watch this. She's learned a new trick.
Hi, everybody. I'm glad my goose going with you. Oh,
She knows hi now.
Yay.
She knows hi now. It's great. It's just like ba 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 ba. That's literally all she does. Ba 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 ba. Which is funny because like we call her Bottle Baba, and I think that's just what she's 8 months old, but she's learned how to say hi. It's awesome. All right, are we finally done with the table here? All right, cool. Tim, do you have it typed in? Sweet. Okay, now Tim, since you seem to be ahead of me, what do I do next?
Enter.
Hit stat again. Thank you. Now what?
Go to
Go to calc. Now what?
Go to 4.
4.
And then calculate.
Go to calculate. Enter. Thank you, Tim. Now, there are 4 variables. How many do I care about, though? 3 of them. I have A, B, and R. Okay? A, just to save some time, is 9.17. B is 338.24. And R is 0.99. This is a what? Correlation. What type of correlation? Positive. Very strong. It is a very strong positive correlation. Okay. A, is that my y-intercept or my slope? A, is that y-intercept or slope? Slope. So I have y equals 9.17 times x. I don't know why I wrote it up there. Plus 338.24. Okay. Now the question says, estimate the number of graduating seniors in the year 2025. So in order to use this equation, I need to do what I did to the table. I need to know how many years have passed since 2012 to get to 2025. There's a real easy way to do it. Take 2025 and subtract it by 2012. How many years passed?
2025 minus 20.
13. 2025 minus 2012 is 13 years. So 13 is my x. So I have y equals 9.17 times 13 plus 338.24. Now I'm in my calculator. Brett asked earlier, how do I get out of the string? Out of this screen? Very easy. Just start typing your equation and it'll just go away. He gone. Sure. So, how many do we expect to graduate?
457.
But you can't have half a student.
Can't have half a student. A student is a student no matter what.
457.
So 457, because that does not round up, that stays the same. So 450 seniors or students, whichever one you want to put. Yep. All right, last page. Woo! Now, question 4 and question 5 are just like the previous question we just did. So out of time restraints, we're going to go ahead and go to question number 7. Ocho? This is 7. So, question number 7 is very similar to question 3, 4, and 5. The only difference is I give it to you in a graph instead of a table. So we need to figure out our x and y values from the graph. Now, same situation is applying here. I have years, 1990, 1994, 98, 2002, 2004, blah, 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 blah. Okay? Now, because 90 is at where x equals 0, what do you think 90 represents? 0. Thank you, Connor. 0. So how many years have passed from 90 to 94?
4.
How many years from 90 to 98?
8.
How many years from 90 to 2002?
12.
12. From 90 to 2006?
16.
From 90 to 2010?
20.
20. Now, the values here is tuition in thousands. So that's 4,000, 5,000, 6,000, 7,000, 8,000. However, we're not going to use the thousands. We're going to use the single digit that it has here. We just need to know that it represents thousands. Okay? So, let's go to our table. How do I get to my table? Stat, edit. Okay? Clear my table. So I hit clear, enter. Clear, enter. Okay? Year 0, 1990. Boom. Then I have what? 4,000, right? Okay. Well, y'all are smart. Okay. I have another dot, but it's in between 90 and 94. What year is that? I have a dot, because I have to graph all the dots. I have a point between the year 2000 or the year 90 and 94. What's in between 90 and 94? 92. So how many years have passed from 90 to 92? 2. Okay. Now let's look at the y value for that. It's between 4 and 5. What's halfway between 4 and 5? $4.5 thousand. Yeah, that's like nothing in college terms. Okay. I do not have. Do I have a dot at 94? No. Where's the next dot at? Between 4 and 8. What's between 4 and 8? 96. So 6 years have passed on that one. Okay. Now, what is the total number of tuition for that? Let's see. It's between 4.5 and 5. 4.75. Think quarters. Think like quarters. 75 cents is between 50 cents and $1. All right. Where's my next dot at? 98. Perfect. Great. Wonderful. Grand. Okay. How many thousands of dollars is tuition? 5. Okay. Then I have another dot at 10. The year 2000, which is also $5,000. I'm just going to go ahead and speed up for time restraints. 12. And that is 7 or 5.5 thousand, not 7. Misread. Okay. Don't worry. Ready? Boom. There it is. Okay. The computer fell asleep on me. All right. Then I have a point at 2014. Okay. Or 2004. And that had a value of $6,000 for tuition. Man, we're really getting up there. In the year 2006, it was $7,000. What? What? Huh? Oh, I'll zoom in. Hold on. Just give me a second. Okay. In the year 2010, or 20 years past, we're at $7.5 thousand. Okay. It's not focusing. There it goes. Are we good? Oh, goodness. Oh, no. I'm telling you, that hat. Ever since you put that hat on. Ever since you put that on. Are we good? Is Kimura the only one that's not good? Okay, so we're going to move on. Okay, so what are the three things we're looking for? A, B, and R, right? Okay, A, B, and R is what we're looking for. So I'm going to hit stat, stat, go over to calculate. What selection? 4, thank you. No one said anything, but I said it anyway. Go to calculate. We are rounding to the hundredths. So I have a slope of 0.17. I have a y-intercept of 3.79, not 3.8, because we're rounding to the hundredths. And then I have a correlation of 0.96. Okay, now let's talk about the correlation first. Strong or weak? Strong, okay, because it's very close to 1. All right, is it, okay, yep, positive. Okay, and then our last word is correlation. It's close to 1, so it's strong. It's a positive because our slope is positive. Correlation. Okay. Now we have everything we need. The line is y equals 0.17x plus $3.79,000. Now it says estimate the year in which the annual tuition will reach. Years is your x or your y? Your X. So that means $10,000 is my Y. I'm telling you, ever since you put that hat on, holy cow, you have literally said everything opposite today. So because time is our X, time is always your X, money is always our Y value, $10,000 is our Y value. Now, in our table, did we put 1,000 or did we just put a single digit? We just put a single digit. So instead of 10,000, what would I actually have? 10. Good. Okay. So I'm going to take my equation, and where I have y, I put 10. Now, the only reason why I put parentheses around the 10 is because I'm trying to show where I substituted. Right? Now, if I gave you this equation, I said solve for x, who can tell me what their first step would be?
Divide.
What?
Divide.
I already substituted. 10 is right there. Why would I divide? How am I dividing? What is the first thing you do? Because then you typed in your numbers wrong. You messed up a number. Okay. What do I do first when I solve this? Guys, this is just basic solving. We already substituted. Thank you. Subtract 3.79 from both sides. That gives me 6.21 equals 0.17x. Now what do I do?
Divide.
Thank you. This isn't new. This is literally what we've been doing for the last month and a half. 2 months. 2.5 months. Oh my gosh, it's getting worse. 6.21 divided by 0.17 is... Anybody? 36.52. Okay, 36.5, or actually 53. However, we're talking about, can I have the year 2026.53? No. What do I need to do? Round it to 37 years. Okay, now 37 years isn't my answer. I want to know the actual year. So I'll take 1990, aka the starting year, and I'll add 37 years to it. And I get the year what? 2027. I just broke my chair.